Stem cells have and will always be a big part of everyone's lives because medications and uh, new drug testing revolves around stem cells. Stem cells are considered to be undifferentiated, which means they don't have a specific job. For instance, skin cells have a, a skin layer and they protect you. Blood cells have a specific job of carrying oxygen. Bone cells are structure. They all have specific jobs, but stem cells do not. They can turn into anything. Um, Stem cells also can find a cure for cancer through research and testing new medications uh, based off of how cells divide and react to certain medications. Um, there's three types of stem cells. There's adult stem cells, which are considered somatic or specific jobs, for instance, like bone marrow. Um, the only drawback of these stem cells is that if you break a bone, those bone stem cells can only make bone. Like, for instance, if you cut yourself, your skin growing back won't grow into bone, it'll grow into skin. Embryonic stem cells can turn into anything, but the drawback is um, you're possibly killing a human being, taking away that life. Um, those can turn into anything and they do not have a specific job. Um, Induced pluripotent stem cells, or iPSCs, are adult stem cells that can also act like embryonic stem cells. Those are the ones that are mostly used in research, but also embryonic stem cells can be used. Those are used from fertilized eggs. Some background information on stem cells. In 1868, the word stem cell was first used in a medical journal, and it was used to describe a fertilized egg that is yet to turn into anything. It had a chance to turn into bone or blood or skin. In 1968, 100 years later, the first bone marrow transplant was performed, and that's significant because it was the biggest breakthrough of the 20th century. In 2009, the government passed legislation saying that they will fund for stem cell research. So any scientist or company would be able to research stem cells as long as they got government funding. Couple purposes of using stem cells. I mentioned before it can find a cure for cancer because if you test anti-tumor medication on specific stem cells, you can see how the cells would react or not react. You can literally see at the cellular level how it would react and if the medication works or not. Another example is drug testing. You don't have to worry about testing it on animals or dogs or people because you can just look at the cellular level and see how that works. For instance, you can see how Advil works on cells instead of worrying about testing it on people and seeing liver problems or liver failure. Some people argue against stem cells because uh, it's more of an ethical dilemma where you could potentially be killing a person or you could not be giving that embryo or that stem cell a chance to live. The Euro Stem Cell Organization quotes, "A human embryo is a human being in the embryonic stage," which they are saying you potentially are killing a person every time you use a stem cell because it's a sperm and an egg, fertilization, and then you stop it. Some people argue against that by saying an embryo or an embryonic stem cell has no chance to live in a petri dish. It needs a woman or a uterus to grow. I mean, if you put an embryo in a petri dish, it will not grow into a human being It'll just stay as an embryonic stem cell forever until it gets information to turn into blood or skin or bone. In conclusion, stem cells open hundreds, if not thousands, of doors for clinical research and cures for diseases or even cancer. Where you stand on the ethical part of that, if you stand against it or for it, that's up to you. Yeah, thanks.